Hello guys, welcome to another video. In today's video, we want to conduct a simple pendulum experiment. And in today's experiment, we want to look at the formula to find the period of oscillation of a simple pendulum. So first of all, let us introduce our apparatus. First of all, we have our pendulum all set up. We have a bottle, is filled with water, is connected to a string, and the string is connected to the ceiling. And we also have a bottle of water so that we can refill the water whenever we need to. We also have our stopwatch. So I have another phone here, which we'll be using as our stopwatch. So here we go. This is our stopwatch here. And yeah, we have our board where we're going to take our readings. So in today's video, we want to prove that the period of oscillation, which is T equals to 2 pi root L over G, is actually dependent on only the length and the acceleration due to gravity. So this means that the period of oscillation does not depend on the mass, does not depend on any other thing apart from the length and the acceleration due to gravity. So that means if I increase the mass of this pendulum or decrease the mass of this pendulum, the period of oscillation will always be the same, meaning that if I do 10 oscillations with a higher mass, the period of oscillation will still be the same, even with a lower mass. If I do 10 oscillations with a bigger mass, the period of oscillation will still be the same. If I do 10 oscillations with a smaller mass, the period of oscillation will still be the same. As far as the length of the string and the acceleration due to gravity, which is your 9.81, does not change. So let's get right into the experiment. Aha. Now let's start this experiment. So first of all, we want to take 10 oscillations of this pendulum. So first, right, we want to take two period of oscillations for this pendulum. So we'll call the first period of oscillation T1, and we'll just leave that there. We don't know it yet. So now we want to do 10 oscillations. So now we have this small mass of water inside the bottle. I want to take 10 oscillations. So we have our stopwatch here. So we're going to take 10 oscillations now. So we'll do 1, 2, ready, go. 9, 10. So for our 10 oscillations, we have our period of oscillation as 0.1975 seconds. 1975 seconds. You can see that right here on the screen of this phone. So now we want to increase the mass of this pendulum bulb by adding more water. So by adding more water, we're actually increasing the mass of this pendulum bulb. So let me take off the bottle cap of this bottle. Let us tie this back up. Yeah. So now we can add more water, which is basically us adding more mass. So this is it. Don't try this at home. Make sure you try it under an adult supervision. So, or you can try it inside your laboratory in your school if you're allowed to do so. So now I've increased the mass. You can see that the mass of water is now somewhere around here. It was previously somewhere below here. So we can then cover the bottle back. And now I want to take another 10 oscillations, and then we want to check, and then we want to write another, we want to take another period of oscillation, which we call T2. Let's write it somewhere below here. So T2, okay, like that. And then we'll restart our timer. So we have reset the timer, it's on 000 now. So now I want to take 10 oscillations. So we have, 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for our 10th period of oscillation, we have 0.1921. Now you can see that the period of oscillation is approximately correct. Let's just say that it's because of air resistance and all those drag that is it's pushing air molecules front and back, and sometimes breeze might come and push it. So that's why it's giving this difference at the end. So the difference in the two period of oscillations should be about plus or minus 0.00554 seconds. So that's the difference in the period of oscillation. Okay, let us try this one more time, right? Let's take another 10 oscillations again. So we want to take another period of oscillation now. We want to do 10 oscillations. So we'll restart our clock. Okay. So restart our clock. That is 00 seconds. And we'll set our mass. Okay. Then 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, right now we're getting a different period of oscillation, but it's still approximately 0.19. So we're getting 0.184. So now we want to increase the mass of this pendulum bulb again, or rather should we even decrease the mass of the pendulum bulb? So we want to, let's just increase it. Increasing it might not cut off the string, but let's just add more mass. Oh, water spilled there. So we're adding more mass of water into the pendulum, and we'll seal this container tightly. Yeah, it's still stable, so that's a good sign. Then yeah, we want to take, see the former time we had. Now I want to reset. Okay, sorry, this is the former time we had, 0.1884 seconds. So we want to restart again. We're in 00 now, and then we want to take our second period of oscillation with still 10 oscillations. So we'll then, okay, sorry, okay, yeah, 000 again. So we'll take 10 oscillations with a greater mass now. So 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, 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 wow. We're getting 0.1861 seconds. Okay, I forgot to write seconds here too. See that? 0.1861 seconds. Very, very close. And we can see that the difference in the two period of oscillations is going to give us plus or minus 0.0023 seconds. That's a difference in these two period of oscillation. And we know there's air resistance and all that, so I guess that is what is causing this difference in the period of oscillation. But as you can see, it is approximately correct. So that's us proving that the pendulum, the period of oscillation of a swinging pendulum, it is independent on the mass of the bulb. You see that we increase the mass, we decrease the mass, we increase the mass. The mass of the mass at T1 was greater than the mass at T2, but we still got the same period of oscillation approximately. So thank you for watching. Click the notification button, subscribe, and wait for another video. You're going to see me in the next one.